Well, today I just thought we'd do a quick video looking at this easy to make curve tracer. And you can get this type design, you can get any classic tester design just looking on the internet for different low voltage or easy to make curve tracers or component testers. So I've been wanting to make one for a while with just a simple 6-volt transformer using 60 hertz. And today I just thought we'd take a look and see how it compares with one that I've always kind of used. And even though I should have over the years taken time to put the curve tracer I use onto a circuit board or make it more user friendly, the type I have on a breadboard with an op amp, do it yourself curve tracer you can make. Just searching the internet for op amp curve tracer or component tester. So I won't bore you with details of what I have here because I'm looking to move from this if I can. It's just kind of a hassle to put this together. I of course have my voltage coming in, my DC voltage that I have to supply, my plus or minus 15 volts that I'm using this chip here. So I have modified it to have an onboard chip. It does my plus or minus 15. I got my op amp. This red lead here is bringing a 1 kilohertz signal in, AC sine wave, from my function generator. I have a snapshot of my shelf right here where my signal generator sits, and I have to have all these components together, of course, along with my oscilloscope. I usually keep this one set up as an XY mode. It is a good bit of hassle. I usually keep it in this little case and just get it out. Although this one works well, could I get by with something as simple as this little octopus style that you can easily search for on the internet? And like I say, the design's vary a little bit, but you can still find very similar circuits. This just happened to be one of the best printed out layouts, so I chose this one. And that's kind of what I wanted to work with for my first test. So I'm going to cut my power supply on. I already have my almost 1 kilohertz signal coming in. It don't have to be exact. I just have it 850 hertz right now. So typically I use this when I want to check components, whether I'm checking the in circuit on a board. Of course, the curve tracer does a great job of doing like an analog signature analysis. If you want to compare a board you already have with another board at the same points, if you want to test individual components and compare them to like components. Now, I do know what to look for on some analog signature analysis or ASA of certain components, and you just know what the curve looks like. And some I just don't. I don't know what to expect. Diodes are pretty simple and pretty self-explanatory, as we have a horizontal voltage bar showing. If I take my test leads coming off and hook to my diode, we should see current. They're right at half a volt. That's about 0.4, 0.45 volts. We see a shift from the voltage to conducting a current here. And we see our voltage turn to a current just over the 0 mark. So somewhere around a 0.4, 0.5 volt forward voltage conduction on the diode, which I expected. Now this is a dual diode that I've replaced on something recently, and this is a common cathode diode, and I know that one of them shorted, so I thought this might be a good example. So I'm going across the tab or the number 2 pins, the same connectivity there. So that will be the cathode. And this is the anode of one diode. And if we look there, it's like a dead short, because if we short our pins out, we go from voltage to a current if we short our pins out. So we know that diode is actually showing shorted. And of course, I found this with a multimeter. I didn't need this, but it's good to see what's going on. And we see that the other half will actually have a good diode. And we can move on right quick to doing capacitors, which is one thing. I think this little bit higher voltage and higher frequency signal, I think it's going to do better with capacitors. So we see our signature oval there. This is very typical for a good capacitor, depending on the size of it, depending on the shape of your oval. We see this oval went from being horizontal to vertical, going from a 0.01 to a 0.047. And this one is a 0.033. And we get our almost perfect circle with that one. And these all have their limitations on capacitors, because your really large capacitors just kind of show shorted. But on your smaller capacitors that are kind of harder to check, these do help with that. But I use these a lot with my semiconductors and PN junctions and on circuit boards checking points. And believe it or not, huntrons and things are used in the industry a lot for troubleshooting down to the circuit board component level. And they do that based on the analog signature analysis, taking a known good board and checking your points and putting your board to be compared. And although it don't help you know exactly what's going on with the board, automatic or systematic check will tell you where the problem areas are, you know, close to a chip or close to a RC network or something that doesn't have the same signature as a known good board. So anyway, I never could afford something like a Huntron or a very nice curve tracer, so I always kind of made my own, even though it's a little bit time consuming to deal with. So that brings us to the point of this video. I've been wondering for a long time, these have been around, I know at least since the 70s, if not beforehand. You can pull a similar schematic up just by searching, you know, Octopus or in-circuit component tester or curve tracer or do-it-yourself curve tracer. And I've always wanted to make one of these just using the 60 hertz low voltage, just resistors, and feed it into an oscilloscope and just see how well it works. And I'm going to bring this over. So those of you that may have an industrial background, you may know exactly what this is. And this is simply an old pilot light transformer, the old Allen Bradley 800T style. And man, there's so many industrial types of these, and LEDs have definitely taken over. So you can find panels with these being thrown out or salvaged because they're ripping them out, all kind of panels, especially back in the late 90s, early 2000s when they were putting in panel views a lot. But this transformer, of course, is for a 755 bulb, and those 755 bulbs are 6 volt. So the reason I have the Kapton tape on here is this is going to be my 120 volts input. I have truly just taken about 5 minutes to get my components together and just solder them on here on the contact points where this transformer used to hook into the push button assembly. I put a couple test leads on here, and we just simply have our 560 ohm resistor with a 100 ohm resistor across and a 1K. I ended up having a 2 watt, but it says 1 watt 1K going across your vertical, your black across to your 560 ohms. So that's what I have here. I've just labeled here with a marker so I know that horizontal hooks here and vertical connect. I got an arrow down and a silver dot here, so even without looking at this, I know my horizontal goes here, my vertical goes here. So basically you're going to go across your 100 ohm resistor. It is really, really straightforward. Although I know this can't do everything that the more complicated circuit can do. Well, just how well does this check? So let's give it a shot. Okay, so back now, I just have this 120 volt to 6 volt Octopus set up here. And I do have my channels, instead of 500 millivolt per division, I have it at 100, because with this 560 ohm resistor here at 6.3 volts, I'm not getting quite as much voltage out as I was getting with my op amp curve tracer. But one thing we know we can do is we could put a variable resistor or a different selector switch setup, however you wanted to do it here, and you could get your different voltage levels. For example, if I just take this potentiometer and just put it across this resistor, see how I can bring this down or bring it up, right? So that's one way you could do it. So you're not limited to this by any means. So just keep that in mind, because we're going to come across some stuff here that at this voltage we just can't check. We could have checked diodes or LEDs rather with this a lot better. But the first thing I want to do is I want to check this diode. And we do see our signature there. Let's try a capacitor. Not enough voltage for a capacitor. But we see if we increase the voltage, we would see our oval. Alright, so this This is a 7824 regulator. We see like a PN junction there. Definitely see a analog signature. It's kind of unique. I have another 7824 that I kept just for this video because I've labeled it as bad. And how did I find this being bad? Well, that actually looks pretty similar. But that looks like it's open. And from here, we still like we're open. So this one has opened up, and it's very evident when you compare it to a known good one. And here's two that I have. So these are C3953 transistors. These are older and I've had them for a while, but I know that they're very, very similar, and they came out of the same device. I'll go to the middle. We go to the middle pin on the outside. We see that. And again, the middle to the outside. So we see our signature is very, very similar. Just take, for example, this potentiometer. We should start to see a shift. With this lower voltage, it doesn't show up in the higher ohms. But we definitely see a transition to the more shorted. And last but not least, we have a older drive SCR. And we see that we are still open on the anode to the cathode. If we take the gate to the cathode, we don't see a change. If we put it on the anode, we see that we get almost 0 ohms, even with this very low voltage. So, because we're down to 100 millivolts per division there, so very little voltage, but it's still enough to at least show the SCR being operational. So a very useful troubleshooting curve tracer, and I mean it really cost me cents. I mean, you know, it's dumpster diving, a few cents, and resistors I already had laying around, so really it cost me next to nothing. Very, very simple circuit. Hope you found the look into this little simple octopus circuit helpful. If you did like this video today, please like, share, subscribe, and thanks for watching. That's just our different functions going in. Got your sine wave, which is what we want. Square wave. And triangular. Sawtooth. One cool thing about this type with a function generator, you can have a little fun here. If I bring up my sweep, get a little cat's eye going on there. So I can sweep through, as we see, we're sweeping through some frequency. Change my rate. We can get some kind of really cool shapes showing up on the XY with some sweep going on. So that's just playing with the sweep on the signal coming in.